Alright guys, I had accidentally marked all of homework 3 as graded without actually sending you your feedback back. So that has been corrected for just about everybody. If not you yet, it will be done so by the end of this afternoon. However, I noticed a discrepancy between what I asked for and what I hoped for in terms of the homework assignment. So I've posted a note on the D2L News about it. But most students, I think you watched the video and you got what I was hoping for. However, it wasn't explicitly in instructions, and that was the program shouldn't crash if you enter bad input, which requires you to use double.try parse rather than convert dot whatever. So if you did this, string s is equal to console.readline. I'm not going to even make it print anything out because this is just a demo. And then you did this. Double D is equal to convert dot to double, Technically that does what the assignment asked for. However, it crashes. So if I run it, and I type in bad data, it blows up. And so in general, try to make your programs as bulletproof as possible. It is so easy to make it not crash on numeric input that I really want y'all to fix that. So instead of that, what we want is something like this. I'm calling it BOK1 because in the multiplication problem it asks for 2 pieces of input. So BOK1 is equal to, double dot try parse parentheses the string and then the word out followed by the variable we want to store it in, maybe D1. So you have to declare D1 before that, of course. Then you do the same thing for the second line of input. Bool BOK2 is equal to, same business. Read in the second string, then try to convert it. Then you need an if statement to make sure that it worked. If BOK1 is equal to true and BOK2 is equal to true, then go ahead and do everything cool. Else, display an error message. Console.write. Now what would be really cool is if it forced them to enter good data, and we could write a method that would do that. But that's really what I wanted. And so what I did is I cut off some points if you didn't make it do that, and if you revise it to do that, then you'll get 100 on the assignment. And some of y'all I counted off late for this assignment, but I'm going to go ahead and give y'all full credit because I'm letting people go back and revise it. So anyways, and by the way, if you do this, if BOK is equal to true, you can just change that to BOK, like that. Just like, if you wanted, you could do if BOK is equal to false, print your error message out. If BOK1 is false, and, well, I put 2 there, and BOK book 2 is equal to false, then print out an error message. If that would be your preferred way, else do it. But you don't have to put equal false. You could just do not BOK1 or not BOK2. I kind of like the way that the equal true and the equal false look like, especially when you're talking about knots, because knots a little bit harder to look at. About to say, please tell me I recorded that. So I updated the instructions. Please use double.try parse. Of course, you have to capitalize the D and the T and the P to ensure the program doesn't crash if the user enters bad data. So hopefully you have enough examples of that. We've demonstrated it in other videos. You can see it now. If you have any questions, ask me about it. The other thing I'd like to ask is that from now on you do include the screenshot as well as the code itself for pretty much every program that you write. That just saves me a small amount of time. I can confirm that the code actually runs because you showed me the screenshot, and then I can eyeball the code more quickly, to validate it, make sure it works perfectly. Otherwise, I have to copy it into a project, compile it, and since everybody is using a later version than I'm using on my school computer, then that takes a little bit more time. I can't just open the solution. So please include screenshots. If you don't know how to do it, then Google it or send me a text. Basically, you just hit the print screen button, which you'll see up there near scroll lock and pause break. Open up Word and paste it, or open up Paint and paste it. So moving to Chapter 5, Looping. So we're going to be learning about while loops, for loops, do loops. If you're a Java developer or a C++ programmer, you've already seen while and for. If you went straight from Python to here, you've never seen do, but it's remarkably easy. How to use nested loops, how to accumulate totals. I think we already did something like that. No, we haven't. That was the advanced Java. Understand how to improve loop performance, and learn about looping issues in GUI programs. So what is a loop? I think we've talked about it before in this class. Certainly I've repeated this statement a lot. There are four kinds of flow of control structures that you can follow. Flow of control just meaning how the code runs. There's sequential, where it just runs code 1, 2, 3, 4 in order. Then there's branching. We've certainly seen branching with if, then, and then the switch case. Then there's looping, and then lastly there are function method calls, which is where it runs out, does some other code somewhere else, could even be in a different file, different class, whatever. And so looping is repeating code over and over and over, because quite often you have a task that you want to run more than once. Video games are all about looping. Get the input from the user about what keys they've pressed, update the positions of everything on the screen, redraw the screen, then come back and get your input again. So it's going to be repeating that over and over and over until the game dies. Until your character dies or whatever. So the loop body is a block of statements within a looping structure. Like this, while x is less than 10, then you could have a whole bunch of statements here. X minus minus, we're going to subtract 1 from 10, and then write line, console.writeLine, the value of x, whatever. And then if x is equal to 3, write line, wow, it's equal to 3. Let's just write ln, sorry, I believe. Now I'm wondering. Anyways, you get the idea. So all the code within the braces is a block of code, a unit of code that gets executed as long as the loop is true. The way it goes is it hits the first line. Is the condition valid? Yeah, it is. So it enters the block. It keeps running. If it hits a break statement, it'll bail out of the loop. You could have something in here. If x is equal to 2, then break. What that means is that when it hits this line, it'll go to the first post block line, whatever it's going to be doing down here. Read in another line with console.readLine or whatever. But ignoring the break statement for now. And each pass through the loop is called an iteration. So this one, depending on what x is supposed to be doing, is probably going to repeat forever, because I said while x is less than 10, if it goes into it all, it's going to keep subtracting 1 from x. That's going to be negative for, that's going to be less than 10 for a long time. So that was kind of dumb. I should have made it x plus plus, right? And then we could have started x off at 0. And this would count up the numbers from 0 to 9. No, it wouldn't. It would actually print out the numbers 1 to 10. I'm used to incrementing the data at the end of the loop rather than the beginning of the loop. And then it would print 0 through 9, because it starts at 0, prints it out, increments it, then it comes back up to the top, reevaluates, and if that's false, then it bails out. So it never actually hits 10 in this syntax. So it goes 0 through 9. It's still 10 iterations. Common mistake is to stick an equal there if you want it to go. All right, now I forgot how to exactly phrase that. Just make sure that if you're starting at 1 and you want 10 iterations, you go less than or equal to 10. But if you're starting at 0 and you want 10 iterations, you just make it less than 10. You can count that out on your fingers and verify that. So it executes a Boolean expression at the top. It's at the top, so this is known as a pretest loop. So of the 3 loops we've talked about, or are going to talk about, the while, the for, and the do loop, this is a pretest loop. This is a pretest loop. And this is a post-test loop. Seems like that should be reversed. It ought to be a pre-loop test, right, and a post-loop test. But anyways, that's how they phrased it. Pretest just means that the condition is tested first before an iteration begins. That is not how I flowchart personally loops, so I'm going to skip that. The while loop consists of the keyword while, then a Boolean expression within parentheses, and then the loop body. You can have a loop that never ends. That code that I wrote there is when I had it subtracting 1 from x was almost an infinite loop. Eventually x would hit data underflow and it would roll over and become a positive value, and then it would stop there. But it's pretty much an infinite loop. An infinite loop is just one in which the condition never becomes false. Simplest infinite loop is while true, do something. This obviously is never going to become false. So if you write a loop like that, you'd better have a break statement inside of it. Otherwise, it's a true infinite loop and it'll run forever. Another infinite loop is if you just don't update your variable. Say I set x is equal to 10, and then I do while x is less than 100. I write, console.write x out, and then I forget to update x. It's going to stay in that loop forever. Nothing ever changes. So infinite loop, one in which the test condition never becomes false. So it runs forever. Does it really run forever? Well, if you cancel the program, it'll stop. If you put a break statement in there, it'll stop. So that's why I put runs forever in quotes. But logically, it'll go forever. Their definition is a loop that never ends. I guess that's more succinct. So making a while loop end correctly, you initialize a loop control variable, you test that variable. They're calling it a loop control variable. When I said x is less than 10, x is a loop control variable. And then you have to alter the value of the control variable. That's if you're not using the while true syntax. So the loop control variable is one that has to be initialized before you enter the loop. Why? Because if you just did this, if a is less than 100, if you never declared a, if you never initialized a, then it can't check a against anything. Which makes me sort of wonder if you could get away with this, and I'm pretty sure the answer is no. Do this stuff, and you initialize a, and you set it to 100 or whatever. No, that's not going to work. You just have to initialize your loop counter before you go into the loop, if that's how you're going to do it. Now in the for loop, you get to initialize the control variable in a slightly cooler way. We'll hit that real soon. So your control variable is usually a counter, right? X is less than, X is greater than. But it doesn't have to be a counter. It can be a flag. Bool be okay is equal to false. And then while be okay is equal to false, or just not be okay. Then get some data from them. S is equal to console.read. Try to convert it. Be okay is equal to, double dot, try parse that variable, store it out in a variable. And if be okay is bad, if not be okay, yell at them, Right line must be numeric input. And it sure would be a good idea if we actually told them, what they were about to enter. Right line, please enter a whole number. No, doesn't have to be a whole number. We were trying to use double dot try parse. So there we go. This is our loop control variable, right? Even though it's not being incremented, it is being updated here. This is one way to write a loop where if you enter bad data, it forces the user to do good data, right? Because if they enter bad data, we print an error message, and then be okay is still equal to false, so it jumps up here and it iterates again. When I'm writing this, I prefer a slightly different approach, which is to use while true and break. So while true, write, please enter a number, read it in. You know that this is obviously leaving, a lot of stuff out. Wouldn't type, wouldn't convert. And then be okay is equal to double dot, try parse, try converting that number. And then, if it's a good number, if be okay is equal to true, great, just break. Otherwise, print your error message. Why do I prefer that? In this case, I don't mind this style of loop. But you'll see something called a priming read, where you read the data, you try to convert it with try parse even before the while loop, and it's only if try parse returns false that you go into loop and you ask for more data. I don't like that at all. You can see, though, the similarities here, but in this case, we're not having to initialize a loop control variable. And, well, that's just what I tend towards using. If you like the other method, that's totally cool. Logically, they're the same thing. So a definite loop is one where you have a counter. You know the number of iterations. So the number of iterations is predetermined. An indefinite loop is one where you don't know the iterations. You don't know how many iterations they're going to be. That'd be like something like while not reached into file, You don't know how long the file is. You don't know how many lines it is. So you're just going to read the data. You're going to process it. Then you're going to get the next line. And you're going to keep doing that until the end of the file. Or it could be something like, please enter a score. They type in a score, and then you type in, do you wish to continue? Yes, no. They type in yes, great, run the loop again. But you have no idea how many times they're going to type yes. So if you're going to use a counter, you actually really don't use a while loop for that. Preferentially use a for loop. So I'm going to say for a definite loop, use a for loop. For an indefinite loop, I'd use a while loop. And for a sentinel value, I'd also use a while loop. That's kind of leaving do loop out entirely. There's nothing you can do with a do loop that you can't do with a while loop. So I may give it short shrift. But anyways, a sentinel value is one. This is the wrong definition. A sentinel value is actually a piece of data with an invalid value that terminates the running of the program. So if you're asking for a score, you tell them or enter -1 to exit. That -1 is a sentinel value. Just asking the user whether they want to continue, yes, no, is not really a sentinel value. That's a user query loop. But according to this textbook, it's a sentinel value. Anyways, when I use the term sentinel value, I mean if you enter a piece of data, but if it's an incorrect value that is defined such as to quit the loop. Enter score or -1 to exit. Enter your name or quit to stop. Hopefully nobody has the name of quit, that kind of thing. So they just type in one thing rather than two things. Because if you're not using a sentinel value, it'll look like this. Enter score. They type in a score. Do you wish to continue? YN. So you have two questions inside your loop. Every time they enter a score, they have to enter a question. Otherwise, you do enter score or -1 to exit, like that. It's just one question, so that they could type 20 the first time, and then they could type in -1 the next. So this is more strictly a sentinel loop, whereas this is more strictly a user query. Let's see if the PowerPoint makes any distinction between those two as we go on. So here we go. This is what's known as a priming read. It's where you get the input first, you convert it, then if it's a valid value, in this case they want to see if you want to see your balance, then you do it, and then you ask them again, do you want to see the balance? You convert it again. I personally hate this style because it requires two inputs, right? You have to, inputs from your part. The user doesn't know, which way that's going. But you have to have your input code and your validation code there, and then later on you have to repeat your input code and your validation code right there. That's why I use while true for this kind of loop. Get their response, and if their response is not equal to yes, then break. Otherwise, do all this stuff. That way you can ignore the getting the input before you go into loop. However, most textbooks show doing the priming read like this. The priming read is the loop, is the code that you execute before you even try to enter the loop to begin with. So a for loop. A for loop is the most excellent loop. It is the one loop to rule them all and in the darkness bind them. So why is it cool? Because it allows you to create the starting value, then test it, and then have the update all in one definition. So if we were going to count from 1 to 10, here's how we would do it normally. Int x is equal to 1, while x is less than or equal to 10. And when I say normally, I mean with a while loop. Do something with x, and then update x. So you have to initialize, and then you have to have your conditional, then you have to have your update. That's three critical things that you have to do in a while loop. A for loop lists all three of those things in one place. For int x is equal to 1, x is less than or equal to 10, x plus plus, do something with x. So you can see that the initializing happens here. The conditional is listed here, and the update is listed here. It works the same way. There's nothing you can do with a for loop that you can't do with a while loop, and pretty much vice versa. But for loops are good for when you have a definite series of values, right? You know you're going to be going from 1 to 10 or 1 to 100 or from 1 to whatever number the user enters. And this is good for indefinite loops, right? you, reading until the end of the file. If end of file equals false, read another line. But here we were able to do with 1, 2, 3, 4 lines what we could do with 2 lines here. I think the syntax is a lot cleaner. When I'm typing code in and demonstrating while loops, I almost always forget incrementing the variable. So I never forget incrementing the variable here. The way it executes is that happens first, then that happens, just like that and that. Then it executes the body. Then it runs back up and increments x plus plus and hops over here. Slight, anyways, that's how it works. If you think about it in those terms, I'm going to do those 2 things, then I'm going to do that, then I'm going to do that, then I'm going to come back and check that again. It seems a little bit weird, but if you just look at the syntax of it and you type it a few times, then it becomes totally logical. That's your initialization, this is your comparison, and that's your update. So the variables created inside any loop cease to exist when the loop ends, and that's true of any block of code. If I do this, if, x is equal to 3, and then I declare a block of code and I say int a is equal to 4, if I try to get out here and do anything with a, x is equal to a plus 7, it's going to give me an error. It's out of scope. A is not available because it's within the braces. Looks like this is going to be a pure lecture one. I don't mind that. On Wednesday we'll come back and we'll do the short assignment. So if you want that value to be accessible down here, you better declare a up here. So I'm surprised that they waited until the for loop to make that point. It's out of scope. You can't see it anymore. The scope is here. Your rifle's looking for your target, but it can only see stuff that's in here. Once you get down here, it's out of scope. I can't think of any other reason to call it scope. So for int I is equal to 0, I is less than 100, so we're going to count from 0 to 99, I plus plus. And if you declare a string here, string s is equal to hello, or you get some input or whatever, then by the time you get down here, you can't do anything with s anymore. If you try to write it out, s doesn't exist. So if you wanted it to exist, you better declare it out of here. Anytime you declare a variable within a pair of braces, it's not going to be accessible outside that pair of braces. And I forget whether this language is one of them, but you can actually do what's known as data hiding in a lot of languages, and you want to avoid this. String s is equal to Bob. Then later on, you declare string s inside the loop. And a lot of languages will go, no, you can't do that. You already declared string s. But other languages go, okay, yeah, you're creating a string, but it's only going to be alive inside the loop. Then when you get down here and you print it out, it's still going to equal Bob, because this one is valid inside the loop, but it never changes that one. They are effectively 2 different strings. So don't recall if C# does that. Just avoid doing that. That's data hiding. If you already have a variable declared, avoid redeclaring it, even if for some reason the language lets you get away with it. So that's the for loop. So a do loop. What's different about a do loop is that the condition is checked at the bottom. Some people also call it a do while loop because the word while does appear in it. So if you have this, x is equal to 10, while x is less or greater than 0, do some stuff with x, write x, then x minus minus. It checks the condition first before it goes in. So if for some reason x is not greater than 0, it won't even execute this code at all. So that's a pretest loop. Now we're going to do a do loop. X is equal to 10. Do some code. Write out x. X minus minus. while x is greater than 0, semicolon. Syntax looks a little bit strange because we're putting a semicolon on this loop where we didn't have to put a semicolon on this loop. And just deal with it, because the reason why we have to have it there is we have this other expression after it. So what this does the exact same thing. This would print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. This would do the same thing. I would print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. But what if this was equal to negative 10? Would it go into that loop at all? No, it's like an if statement. If negative 10 is greater than 0, heck no. So don't do those two things. It would skip those two things entirely. Here, if we set it equal to negative 10, it'd go ahead and do it. It would print x one time, then it would subtract 1 from it, so it's negative 11, and then is negative 11 greater than 0? No, it's not, so it'd fall out of the loop. So the rules of thumb: use a do loop if the body of the loop must be executed at least one time. And people do kind of menu programs, press 1, 2, or 3, to do something, and then do you wish to continue? Yes, no. And then they base their while loop on that. Do you wish to continue? Yeah. Because you're going to want to do that menu stuff first. Then our second condition: use a for loop if you are processing a definite series of values. Otherwise, use a while loop. And if you're determined, you can rejigger a while loop to do anything that the others two do. But it's very appropriate to use a for loop to process a series of values. And it's appropriate to use a do loop if you know that you're going to execute the code at least once inside the loop. So the do loop is a post-test loop. The other two are pre-test loops. You can nest loops, and this will be about the last thing we do. When loops are nested, each pair contains an inner loop and an outer loop. You can also nest a loop inside of an if statement, or nest an if statement inside a loop. The loops can never overlap. The inner loop must be entirely contained within the outer loop. So you could do this. Int x is equal to 0. Now let's start it off at 1. Heck, let's use for loops. For x is equal to 1, x is less than or equal to 10, x plus plus. Then you do for y is equal to 1, y is less than or equal to 10, y plus plus. And then inside there, let's print out x and y. Right line, 0, 1, comma x, comma y. So we'd enter the loop. All right. Right now, x is equal to 1. Then it would slip into this loop. All right, y is equal to 1. Then it would write those values out. So it would write 1, 1. Now we haven't exited this loop yet. Y would get incremented, and then it would iterate again. So it would print y2. Let's lower these numbers, just so it goes out to 3 rather than 10. Then y gets incremented again. The condition is checked. Y is equal to 3. It's not ready to exit the loop yet, so it would print 1 and 3. Then it increments it again. It checks the condition. Y is now equal to 4. Is 4 less than 3? No, it is not. So it bails out of that loop. We are here now, which means that we're going to get this brace. We're going to pop back up, and we're going to add 1 to x. Now x was equal to 1. Now it's equal to 2. Then we go back in here. Y is equal to 1. Same thing. now we're inside this loop, so we're going to print out 2, 1 because we had incremented x. And then we're going to print out 2, 2, 2, 3. Then it breaks out of this inner loop, comes down here, goes back up, iterates, adds 1 to x. X is still less than true or equal to 3, so then it comes back in and does the inner loop again. And you can see that it runs through the inner loop completely before it leaves the inner loop, jumps back up, iterates, and checks the condition. So one more run through, it would print 3, 1, 3, 2, 3, 3, like that. So you can see the inner loop control variable getting incremented each time. 1, 2, 3, 1, 2, 3, 1, 2, 3. And there's one thing I want to do to play with this, which is to print out a rectangle. So I'm going to create a new project, C# console application. Let's declare a string. Let's declare 2 ints called height and width. Then let's ask them, s is equal, well, guess we got to tell them, console.writeLine, or just write, what is the height of the rectangle? Then read it in, s is equal to console.readLine. Then we have to check it, so bool BOK1 is equal to double.tryparse. Takes a little bit more effort, right, to do this, but it's worth it. Double.tryparse, parentheses s, comma, out, comma, or out space height. What are you complaining about? Oh, I declared int and height as ints, so it's going to be int dot tryparse. Integer dot tryparse. Let's get all picky on us. All right. Really? For Pete's sake. And Google is our friend. C# int tryparse. Okay, int 32. That's right. Okay. So, BOK1 is equal to int 32 dot tryparse. Let's get the second value now. Console dot IntelliSense bugs me sometimes. Right. What is the width of the rect? S is equal to console.readLine. We're going to try parsing that one now. BOK2 is equal to int 32 dot tryparse parentheses s out space width. All right, now we have 2 values, but we need to make sure that the parses worked. So if BOK1 and 2 ampersands BOK2, then we have some good stuff. Else, we have a problem. So I'm going to handle that first. In my else clause, I'm going to do console.writeLine bad data entered, or non-numeric data entered, or non-integer data. All right, now we have a height and a width. We can iterate with a nested loop enough times to print out our rectangle. Yeah, and you thought we were going to draw it with graphics. Nope, we're just going to print it out. So we need a loop for int h is equal to 0, h is less than the height, h plus plus. We could have started at 1 and gone to less than or equal to. As our nested loop, for int w is equal to 0, w is less than width, w plus plus. Now we can print out an asterisk or whatever our happy symbol is. Console dot right, not right line. We just want right because we wanted to put everything on the same row until we're done with the inner loop with the nested loop. So how about an asterisk? Once we leave the inner loop, we're done with that row. So we want to go to the next row. So we're going to do a console.write line. All right, that should do it. That prints out a rectangle of height, number of rows, and width, number of columns. And you do the same thing in order to print out a two-dimensional array. So when we get to arrays, we'll be doing the same thing. What is the height of the rectangle? It's a 10 rectangle. What is the width of the rectangle? It's 3. And it blows up. All right, instead of putting that read key down at the bottom, you can just do debug start without debugging, and it'll keep the window open. I wish it'd keep the window by default. Okay, so it's a 10 by 3, and it prints out the 3, 3 wide, 10 tall. Now I hope that makes sense. Why is it 3 wide? Because that's the inner loop. We're checking against width inside our inner loop. Why is it 10 tall? Because that's our outer loop. And that's how many times the whole thing. So you could put the comment rows here and columns here. All right, that's enough. One of our homework assignments is going to be to print out rectangles. Let's stop here. I am going to take some braces out just to get some more code on the screen at the same time. I really don't approve of doing that, but that way, well, that broke it. I guess that's why I don't approve of it. All right. All right, that's our main from there to there. You can pause it and type it in or whatever. One thing to mention here, should have mentioned a little bit earlier, is that C# is one of those languages that does integer division. Meaning that if you have two ints, x is equal to 1 divided by 2, it rounds it down because both of those are ints. If you printed it out, x would then equal 0. Very counterintuitive, huh? But that's the way it works. If you wanted it really to be 0.5, one of these would have to be a floating point number. 1.0 divided by 2. Then x would equal 0.5. I guess these are some good notes worth saving. Okay. Let me clarify that. So both operands of the division operator are ints, the result is 0. But if one or both of them is a floating point, then the result does not get rounded down. So we'll make a Dropbox for this. Go ahead and upload your rectangle program into the Dropbox.
Could I see your loop to print out the rectangle?
Sure. There's our loop to print out the rectangle. If I was going to do what I'd done before, I'd put a console.read key right here. And I've had the question, how does that close the program? It doesn't close the program, it stops the program from closing.
So
Otherwise, runs the entire program and then closes it before you get to see the output. So we stick a read key in there to pause it, so the user actually has to hit enter or close the window.